Here's a review key on for 6A test. Number one, I'm on these problems. I'm going to deal with any negative exponents first. So number one, I've got this negative exponent right here. I'm simply going to change that to 1 over 3x to the 5th, and then I can square it. This other one does not have a negative exponent, so I'm going to leave it. You can put it over 1 if you find that helpful. On the left, I need to square everything inside. 3 squared is 9. And then x to the 5th squared is x to the 10th. You got to multiply the exponents. We're on the right, got to take everything to the 4th. Negative 2 to the 4th is a positive, because 4 negatives is positive. 2 to the 4th is 16. And again, 2 times 4 is how you get your exponent for the x. 2 times 4 is 8. You could multiply straight across and reduce, or you could say there are more x's on the bottom right now. Say there are 2 more x's on the bottom. 16 and 9 don't have any common factors, so it's 16 over 9x squared. Number 2. If you're comfortable with the negatives, you could say where is there more x's and say 3 is 5 bigger than negative 2. Or you could flip the ones that have negative exponents. So on the top, I got x to the 3rd, y to the 6th. That's the stuff here. And then I'm also going to bring up that x squared. On the bottom, I've got my 25, y to the 3rd, z, but there's also this z here, so I'm going to bring that down and write z. You can write z to the 1st or just z. Both of these are actually z to the 1st. Okay. 10 over 25, reduce it. 5 goes into both. 10 divided by 5 is 2. 25 divided by 5 is 5. All the x's are on top. There's 3 here. There's 2 here for a total of 5 x's on top. The y's are split. Some are on top, some are on the bottom. Where's there more? On top by 3. 6 is 3 bigger than 3. 6 minus 3 is 3. And then the z's are both on the bottom. Z times z is z squared. Okay, number 3. All right, I would deal with the inside here first. So I would take the x to the negative 2nd and move it down. So it'd be 5x squared y to the 3rd, the negative 3rd. On the right-hand side, we could switch the y's and the x's because they're both negative exponents. So it becomes y to the positive 9th on top, x to the positive 6th on the bottom. Do a step with this first part here. That's the negative 3rd. I could take the whole thing and flip it. And that allows me to change this to the positive 3rd. I'll just write the second part. Now I'm going to take everything over here to the positive 3rd. 5 to the 3rd is 125. X squared to the 3rd is x to the 6th. 2 times 3 is 6. Y to the 3rd to the 3rd is y to the 9th. 3 times 3 is 9. 6 to the 3rd is 216. Okay. Now I'm going to reduce numbers. I like making things smaller instead of bigger here. So I'm going to reduce 125 and 25. 5 goes into both, but so does 25. So let's take 25 out of both of them. That would make this a 1 and this a 5. Okay, what goes into both? 12 and 216. Wouldn't it be nice if 12 went into 216? I believe it does. 12 goes into 12 once. And if you put 216 divided by 12 in your calculator, you should get 18. So what I have is 5 over 18 for the numbers. Letter-wise, where's there more x's? Well, it's a tie. I got x to the 6th and x to the 6th. So they just undo one another. They cancel each other out. And then on top, I got y to the 9th and y to the 9th. That's y to the 18th. So it's 5y to the 18th over 18. Okay, moving on to number 4. It says 4th root, negative 16. You cannot even root a negative. So it's the second root, which is the square root, 4th root, 6th root, 8th root. You can't do that and get real roots. So this has no real roots. 4th root of 625, you can do what to the 4th of 625, 5, but since it says all of them, you need to put plus or minus. If you don't put plus or minus, you're not going to get full credit. Number 5 says 5th root. Now, 5th root is an odd root. 5 is odd. You can 5th root anything. If I 5th root a negative, I get a negative. And what to the 5th is 32? 2. If I 5th root a positive, I get a positive. And if I look at my half sheet, how far down is 59,400 or 59,049? Looks like it's 9 down. So 9 to the 5th is 59,049. Okay, 6. Just use absolute values. Be careful. Remember, we're looking for even, odd. So 6 could have absolute values because it's a square root, which is even. So we got square root of 41. That's 21. And then all we do is, think of this as a 2 when we divide. 10 divided by 2 is 5. 12 divided by 2 is 6. There's nothing left on the inside. Were there any even, odds? Well, this was even, and that guy right there is odd. That one needs an absolute value. The y has an even at the end, so you don't need to worry about it. 7, 80. Now let's see, 80 breaks down into 16 and 5. Let's get a 4 on the outside, 5 on the inside. A to the third is the same as a squared times a. So you can take an a out and then leave an a in. 3 divided by 2 is 1 on the outside, and there's a remainder of 1 on the inside. And the b's would be 6 divided by 2 is 3. Now, is there any need for absolute value? Well, it was an even index. It was 2. This was even. The 6 was even. And there's an odd right here. So it should have been 4a. Absolute value would be square root of 5a. Okay, so that a to the third in the inside, I thought of that as a square root of a squared times the square root of a. And that part right there turned into the a on the outside. Okay, third root of a negative, 343. Third root of negative 343 is negative 7. I don't have to worry about absolute values here because 3 is odd. 9 divided by 3 is 3, so it's x to the third. There's not enough y's to come out, so there's going to be a y left on the inside. And z to the 5th, I can think of as z to the third times z squared. So I can take out one z, and then there's 2 z's left on the inside. Okay? This right here is just z, and then there was 2 left behind. Okay, so negative 7x cubed z times the third root of y z squared. Number 9, third root of 375b to the 5th. So look at my third power column on my half sheet, and I see 125 goes in there. So 125 goes into 375 3 times. I can think of b to the fifth as b to the third and b squared. I like that b to the third because then I can make it a regular b. So third root of 5, 125 is 5. Third root of b cubed is b. And then 3b squared is left on the inside. Okay, fourth root of 160. So I look at my fourth power column, I'm looking for things that go into 160, and I see 16s on there. I can think of this as 16 times 10 is 160. And then I got x to the 10th. Well, I can think of x to the 10th as x to the 8th and x squared. Y to the 12th is good because 12 is divisible by 4. So, fourth root of 16 is 2. Some of you have been treating it like 4 because you accidentally changed it to square root. So careful. Fourth root of 16 is 2. X to the 8 divided by 4 is 2. Y to the 12 divided by 4 is 3. And leave the fourth root 10x squared. Was there any need for absolute values? Yeah, it looks like the y would need it because it was even, and the 3 is odd. So I need to have absolute values there. 11. Seventh root of 8748. I'm looking at my seventh power sheet. I don't see 8748 on there. So either 2187 or 128's got to go in there. If I do 8748 divided by 2187, I get 4. So that worked out nice. So this is the same as 2187. The seventh root of 4. Now I got x to the 20th. I can think of x to the 20th as x to the 14th times x to the 6th. I chose 14 because 7 goes into it. Y to the 8th, I can think of that as y to the 7th times y. 7 is divisible by 7. So now I'm set up to simplify. Seventh root of 2187 is 3. 14 divided by 7 is 2. 7 divided by 7 is 1. And I got seventh root of 4x to the 6th y. No need for absolute values because our index was odd. Has to be even, otherwise you don't have to worry about it. Okay, number 12. Let's see, we can assume all variables are positive. That means we don't need to worry about any absolute values. So I'm going to proceed by looking to reduce and cancel some stuff. They're both fourth roots, so I can treat these as it's one huge fourth root and just reduce. What I mean by that is like this. And then just go through and reduce. 8 over 6 is 4 over 3. There are more d's on top by 1. There are more e's on the bottom by 2. And I got f to the third. Now these are still supposed to really be fourth roots, and I'm going to go back and write them individually as fourth roots. So I'll simplify first. Next, I can't have root in the denominator, so I'm going to multiply top and bottom by the fourth root of whatever takes care of the bottom. Now, what do I mean by that? The bottom has a 3, and what I would like to have is 4 of those. So I have 1, 3, that means I need 3 more. I have 2 e's, that means I need 2 more. Plus 2 is 4. And I have 3 f's. So I need 1 more. 1 plus 3 is 4. So that turns it into fourth root of. On top, I would have 4 times 3 cubed d(e) squared f. And on the bottom, that whole bottom mess turns into 3e F. Because they'd all be fourth root of everything to the fourth power. So the bottom's just 3EF. And we're pretty good here, but I would want you to actually do 4 times 3 cubed. That'd be 4 times 27, which is 108. Okay, so same deal over on 13. I'm going to simplify first. 54 divided by 2 is 27. There are more y's on the bottom by 1. So I can change that to just y. Notice it's x to the 4th. Now, because it's x to the 4th, I can actually take on an x. So the next thing I'm going to do is actually simplify. First, third root of 27 is 3. And on the bottom, I can take out an x. You know, that's because I can think of x to the 4th as x cubed times x. Right? So that turns into this plain old x, and then there's 1 left behind. Now, I multiply top and bottom by whatever gives me a power of 3 in the denominator, or in the radicand here. So I got x the first, y the first. The index is 3, so I need x squared, y squared. I get 3 times the third root of x squared, y squared in the numerator. On the bottom, you got that x on the outside. And you have the third root of x cubed, y cubed. Which turns into x times xy in the denominator. Numerator. And then I wouldn't leave that because x times xy can be simplified. So here's my numerator one more time. My denominator would actually be x squared y. Okay. 14, I can't reduce anything. So I'm just going to go ahead and multiply top and bottom. I've got 1, 2, so I need 4 more. I got the 5th root of 7 times 2 to the 4th on top. The bottom is the 5th root of 2 to the 5th, which is flat out 2. Do 2 to the 4th, which is 16. Take it times 7. So that'd be 70 plus 42, 112. 5th root of 112 all over 2. Okay, 15. A lot of ways to do it. I guess I'd suggest just go ahead and multiply them first. 6 times 2 is 12. You got the 4th root. Multiply this inside stuff together first, or next. So that'd be 4 times 12, 48. X to the 3rd times x to the 6th is x to the 9th. Okay, so bring down to 12. And then we're going to change this into the 4th root of 16 goes into 48 3 times. So 16, you go to your half sheet, 16 is in that power 4 column. And I'm going to change this to x to the 8th and x to the 8th times x to the 9th, because that'll allow me to simplify. 4th root of 16 is 2. 4th root of x to the 8th is x squared. Just do 8 divided by 4. And then this stays put. And finally, 12 times 2 is 24. This is the same thing. Multiply. 16 times 4 is 64. X squared times x to the 7th is x to the 9th. This one comes out nice. The 3rd root of 64 is 4. And the 3rd root of x to the 9th is x cubed. 9 divided by 3 is 3. You cannot add those. They're not like terms, so you got to break them down. Go to your power 4. And if you go to your power 4, you'll see that 16 goes into 32. twice. And then 81 is actually a power of 4. It's 3 to the 4th. 3. So we have 2 4th root of 2 plus 3. You can't add those up. They're not like terms. That'd be your final answer. Another one similar to that. Break it down. What goes into 30, 135? Looks like 27 does. 27 goes in there 5 times. Okay, so the front turns into 3 times the third root of 5. Third root of 27 is 3, then you're just left with third root 5. So the front term is 9, third root 5. Go to the next one. In a perfect world, we're going to be left with the third root 5. So what I would do is 1080 divided by 5. And if I do that, I get 216. And 216 is a power of 3. It's 6 to the third. I got minus 6, third root 5. And finally, the last one I don't have to do anything with. It's already ready to go. And now they're all like terms, so I just put the front numbers together. 9 minus 6 is 3. 3 plus 2 is 5. And you don't do anything to the inside, so it's 5, third root 5. 19, you could either square dance it, or if you feel more comfortable, you could write it twice. You need to do 6 times 6. Then you need to do 6 times 2 root 5. And then you're going to do 2 root 5 times 6, which is the same as 6 times 2 root 5. And then you need to do 2 root 5 times 2 root 5. Alright, so I got 6 times 6, 36. 12 root 5. 6 times 2 is 12. 12 root 5. This one here, I got to do 2 times 2 is 4, and then square root 5 times square root 5 is 5, right? Because it's the square root of 25, which is 5. So then this turns into 20. So I'm going to have 36 and 20, 56, and then 12 root 5 and 12 root 5 go together to make 24 root 5. Couple more. 20, I've got conjugates. When I multiply conjugates, I can disregard the middle stuff. It's going to cancel. If you did the middle, you'd have 50 root 2 and negative 50 root 2. Those would go away. So I just need to focus on. So focusing on the front, so I got 10 times 10 is 100. And negative 5 root 2 times 5 root 2 would be negative 25 root 4. So 100 minus 25 times 2, 100 minus 50 is 50. So number 20 turns into just the number 50. 21, can't have a root in the denominator, so you're going to multiply top and bottom by the conjugate, which would be square root of 6 plus 1, square root of 6 plus 1. So on top, make sure you think of this as being in parentheses. On top, you'd have 1 times root 6, 1 times 1. Then you'd have negative root 2 times root 6. And then you'd have negative root 2 times 1. On the bottom, you'd have root 6 times root 6 minus 1 times 1. You don't have to worry about the middles on the bottom because they're conjugates. On the top, I got root 6 plus 1 minus root 12 minus root 2. On the bottom, I got 6 minus 1. On the top, I got square root 6 plus 1 minus 2 root 3. Square root 12 is square root 4 times square root 3, which is 2 root 3. Minus root 2. 6 minus 1 is 5. There are no common factors of all 5 terms here. There's 1, 2, 3, 4, 5 terms. Okay? They don't have any common factors, so I don't have to divide them all. There's my answer. Get rid of those dots for you. Right there. That wraps it up. I hope you found the review video helpful, and do well on the test tomorrow.